This is the Physical Activity Researcher Podcast, a podcast for researchers of sedentary behavior, physical activity, and sports. Join for a relaxed dialogue about research design, practicalities, and, well, anything related to research. Learn from your fellow researchers useful and relevant information that does not fit into formal content and limited space of scientific publications. And here is your host, researcher and entrepreneur, Olli Tikkanen.
Welcome everyone. I'm very excited about today's episode as we are going to talk about accelerometry and activity tracking. Our guest, expert in the theme, is working as an assistant professor of integrative physiology and health science at Alma College in Michigan, US. He studies the accuracy and reliability of various physical activity monitors and also uses them as intervention tools to help individuals become more physically active. Ladies and gentlemen, I'm honored to introduce our guest, Assistant Professor Alexander Montoye. Welcome, Alex.
Thank you, Ali. It's great to be on the podcast.
Fully my pleasure. So you've been looking quite a bit activity tracking among athletes or sport-specific contexts. Mm-hmm. What do you see as the most promising things? Is it for research purposes, or do you see that the athletes would actually benefit from them in their training? What do you see as the most potential things?
Yeah, that's a great question. So the research we've been doing, I would say eventually the goal is to help specific athletes or help coaches to understand when their athletes are ready to return to sport safely, or what restrictions they should have in practices, or maybe how many minutes they should be limited to in a game setting. Certainly that is the future goal with our work. We are not there yet. Although a lot of your more commercial type companies have moved into that realm of activity tracking and feedback that's specific to the individual. So just for example, a couple brands that come to mind. Catapult is a system that I know my research collaborators at Michigan State use in a lot of their athletic teams. So Catapult is a chest worn accelerometer. And I believe it has heart rate as well. So it's a multi-sensor device. And then Catapult does a lot of the outcomes derivation, I guess. So they're not like Michigan State's not looking at the raw data. Catapult's got some proprietary algorithms for translating that into activity intensity, or they'll report outcomes such as volume or training load. And so coaches, strength conditioning specialists can look at that data and then for specific players, see who has the highest training loads, maybe try to scale training or practices so that the training load you're getting in a practice is similar to the load that you're getting in a game situation. Or they can make sure that people aren't. So let's say, you're coming off the summer, and especially this summer, it's been bad in terms of, at least here at Alma, very low engagement in practicing in the off season because there just is not access to gyms right now with everything closed. And so we could look at a training volume for an individual when they come in and say, you're at the training volume of, just to use some arbitrary numbers, let's say 10. In a match or a game play, you're going to have to be at a training load of 100. So how do we develop a training plan that can progress you up at a rate that you're not likely to get injured, but also allow us to know when you're ready for full participation in gameplay, if that makes sense. So there are companies like Catapult. Mm-hmm. I know Hexoskin is another one. That's actually a compression shirt that has sensors in it. It has heart rate. It does breathing rate and depth. So you get a ventilation variable as well as an accelerometer. And so that can give you a lot of individual data. And so you can, again, compare training to gameplay type situations. So there are a number of commercial technologies that seek to make the outcomes very easy for the end user to get, and then make decisions on for individual athletes to help them manage injury, return from injury, increase training volume, that type of thing.
Mm. And what's your take? Would you recommend these to coaches? Do you see that they provide true value when they are used, or how do you see the current state?
I think, and this is getting a little bit out of my area, but my guess would be that when they're used appropriately, they probably are effective. And so, uh, most of the places that use these are not especially cheap technologies. I'm not fully aware of what Catapult costs, but it's more expensive than certainly like the research grade devices we use, so actigraphs or gene active accelerometers. These Catapult or Hexoskin type technologies are more expensive than that, and so you're not going to have a local rec league team purchasing these for their athletes. I mean, they're a little bit restricted to, for us it's going to be collegiate settings or semi-professional or professional type organizations, which I think is probably good in the sense that if you're going to pay the money, invest in this technology, you also want to invest in somebody who will have the capacity to understand and be able to make informed decisions on it, right? So if you just gave this technology to somebody and told them how to use it, it would be a little bit difficult to be able to meaningfully take that data and do something with it. So you kind of have to have a team of people then that can collect the data, analyze it, and then ultimately make training-based decisions on who needs to be doing more, who maybe should scale back, who didn't come in at an appropriate fitness level to be doing what they're doing, those types of things. So I think, yeah, when they're used right in the proper settings, they certainly can help. And that's something I've been very happy to see at the kind of higher levels of sport over the last 10-ish years, I would say. Huge adoption of these types of technologies and collecting data to understand training loads or physical activity volumes. That was something that, with as much money as there is in organized sport at high levels, it was amazing how little data that they had to support training practices or return from injury and those types of things. And I think those decisions have become much more data driven and thereby much more effective in recent years.
So quite a good. You can find quite the good new variables for sport specific context, as those haven't been studied that much before. How do you see for daily activity, sedentary behavior? Do you see some potential new outcome metrics that could maybe better relate to health outcomes or something else?
That's a good question. I know over the last few years, as our monitoring devices have changed, they've shrunk in size, people are trying them on different body locations, and our analytic techniques are getting better. The consumer monitors, I think, have helped in a lot of ways to increase familiarity with activity monitoring and device-based measures. I think really one of the things I think is going to be important moving forward is recognizing this idea of the 24-hour profile. So much of our research historically has been looking at moderate to vigorous physical activity in isolation, or total daily steps in isolation, or even sedentary behavior in relative isolation, without really taking into account that those variables are all interconnected, because we live within a 24-hour day. If we increase our sedentary behavior, that has to replace something else that we were doing before. So that has to mean we're doing less. If we're to take less sedentary behavior, it has to mean we're doing more light or moderate or vigorous intensity activity. Or if we're doing less, maybe it's because we're sleeping more, and so there's less time that we're awake to engage in activity intensities. And so I think that as we use device-based measures, trying to capture an entire 24-hour window for people, and then being able to separate that out into what is sleep versus not. Is there any time where we don't think the monitor was worn? We got to remove that. And then within our time that we're awake, can we divide it up into our activity intensities? I think that's going to allow us a much better understanding in terms of how those variables interact with each other. I've always, one of the questions that's intrigued me is the difference between sedentary behavior and sleep We consider time spent sedentary, so in a seated lying activity with low energy intensity or low energy expenditure, that's typically viewed as negative for health. Sleep is viewed very positive for health in terms of the benefits, but from an energy expenditure perspective, that's the lowest energy expenditure time of your day. It's a very extended period sedentary. And so we know that people who are awake and sedentary for prolonged periods see issues in terms of blood pressure changes or insulin sensitivity changes. And so trying to separate sedentary behavior awake from sleep, which from a postural perspective or an energy perspective look very similar, but they have very, very different physiologic outcomes. I think we need to be able to separate out what those, I guess I would say 5 variables are: sleep, sedentary, light, moderate, vigorous activity, to really understand what are the key things we should focus on to improve health at a population level.
Yeah, that's an interesting point relating to sedentary behavior and sleep. But I guess the hormone milieu in the body is very different. So I guess
Sure.
that's the reason why sleep is beneficial for you, while
Sure.
sedentary behavior is not.
Yeah, absolutely. I would not recommend that anybody sleep less to reduce their sedentary behavior. But just to understand that accelerometers capture movement. And so from a movement perspective, sleep and sedentary behavior may look very similar, whereas you're absolutely right. The health effects of those are almost, extreme opposite. And so the challenge comes in from a measurement perspective. When most people are going to be sleeping. It'll start between 9 p.m. and maybe midnight, or at least you've got a window when you can expect sleep to start. And then you would also have a window where you'd expect sleep to stop in the morning. What's much more difficult, and I've seen a little bit of research try to capture this, but let's say somebody naps during the day. How do you learn to recognize when sedentary behavior during the day is in fact not sedentary awake behavior, but rather a nap, which actually might be a good thing for physiologic function, whereas just prolonged sedentary behavior wouldn't be, right? And so some of those things are real challenges when we're using device-based measures, is understanding if the posture corresponds to, in that example, sedentary behavior or sleep, or even within other postures. So if we know someone's sedentary and awake, is that something that's modifiable or not? Right? If you're sitting at a desk for your job and you need to be sitting at your desk for your job, that's not really a place we can intervene or try to suggest that you change your behavior. Whereas if you're being sedentary at home watching TV in the evening, maybe that is a spot we have better likelihood of being successful if we're trying to change your behavior, right? So I think that's an important piece to keep in mind, more of the domain rather than just let's say the activity intensity.
Yeah. And you mentioned the napping. Do you see any possibility with time sequence and using machine learning that you could actually capture when the people are napping and not just having a long sedentary period?
Yeah, that's a good question. I possibly I think so. I'm thinking with sedentary behavior, typically we consider a thigh worn accelerometer is probably the best, or maybe something in your pocket if it can sense the angle of your upper leg. And the reason for that is that, like with a hip worn device, your hip is at a very similar position, as well as amount of movement when you're sitting versus standing versus, well, I guess lying down, it would be 90 degrees rotated. But it's a difficulty with a hip worn device tracking sedentary behavior, whereas a thigh worn device is much better. One of the initial challenges with the thigh worn device, though, was differentiating sitting from lying down, because in both of those situations, your upper thigh will be parallel to the ground. And so what I've seen success with over the last couple of years is people looking at not just the vertical axis, which would tell you whether you're perpendicular or parallel to the ground, but also looking at the medial lateral axis, with the idea that most people probably don't sleep on their back. They may sleep on their side or on their stomach. And so you can use that axis then to understand the body, the leg position, to be able to differentiate lying down from sitting. Because I think that's really important when we're trying to capture napping activity, for example. Someone's less likely to nap while sitting than they are if they're lying down. in the day. So that would at least be a step toward capturing daytime napping. Something else like a time sequencing that may be informative, or even other sensors. So if we had a heart rate sensor that was involved, there would probably be a much lower heart or a lower heart rate if they're napping than if they're sitting or awake, or also breathing rate, because some devices can capture that. That might give an indication on if somebody is asleep versus awake. So there are some interesting additional sensors that may be informative if you are interested in capturing a behavior like that.
Yeah, that was a good point about thigh-worn device, that you cannot really sit in a way that it would be sideways, like if you laying down on your side.
Yeah.
So could you use the time sequence that if it detects that the thigh is on the sideways, and even if after that it goes to the other position, you can pretty well expect that the person is still laying down.
Yeah, that's a good point, and I would expect that you probably could. So within, let's say you identify that this afternoon from 2 to 4 p.m., somebody has a prolonged sedentary episode, according to a thigh monitor. And then within that, if you dove down deeper or tried to look more granularly at the data, did they have a period in which they were rotated 90 degrees, which, as you suggested, would suggest they were lying on their side, because there's not really any way to sit where your leg would be at that type of an angle. And then, yeah, if they had that, you probably could go back and say, okay, well, this period from 2 to 4, it's very likely they were lying down. And if you're lying down in the afternoon, is that a nap? At least you could label that as a potential nap situation. And then when you analyze your data, you could treat it as a nap or treat it as not a nap, and see if that changes your assessment on whatever your outcome measure is.
This podcast is sponsored by Fibion, a research device that has been shown to be valid in tracking sitting, standing, physical activity and energy expenditure. Furthermore, Fibion has been shown to be valid categorizing physical activity into light, moderate and vigorous intensity. In addition to scientific accuracy, Fibion provides automatically produced and easy-to-understand reports for research participants. Get scientific validation and learn more about Fibion at fibion.com/research. Fibion, from researchers to researchers.
And if we talk about the wearing locations, you have analyzed a lot of data, and
Yep.
all of the wearing positions have their pros and cons. So what would be your recommended wearing locations for different research settings?
That is the $1 million question, isn't it? So the trade-offs. So the wrist location is enormously popular right now, and there are some real upsides to that. The first one is compliance, because people are used to wearing wristwatches, and because almost all consumer-based activity monitors are worn on the wrist. I think there's a lot of willingness for participants to wear a device on their wrist. The other nice thing, so you get really high compliance. That 24-hour wear idea is much more attainable with a wrist device than it's likely to be with a hip device or something like that. So that's one big advantage of the wrist. The other advantage of the wrist is sleep measurement seems much more or is much more highly researched using a wrist-worn device than it is if worn on the ankle or the hip, or even the thigh. There is some research with those other device locations, but it seems like you would get the best data in terms of sleep assessment using a wrist-worn device. And then the other piece that we've seen a little bit of, depending on what your outcome measure is, if you're interested in looking at specific types of activity, there may be some settings in which a wrist-worn device can work well for you, because your wrist movement may be more unique than your hip movement. So if, for example, if you're doing different lifestyle activities, if you were vacuuming a floor versus washing dishes, that would look very different at the wrist. It probably wouldn't look all that different at the hip. And so if you're trying to understand very specific types of activities, there may be situations in which the wrist is more informative than other body locations are. The disadvantages of the wrist, of course, is that in terms of activity intensity, what your arms are doing often don't correspond to what the rest of your body is doing. And so for energy expenditure or activity intensity, typically what we've seen at least is that the wrist placements are not as effective at capturing those than if the monitor is worn either close to the center of the body or even on the lower body, because your main energy expenditure through most daily activities is going to be ambulation. And so if you have a sensor placed on the ankle or the thigh or even the hip, you'll be able to capture those ambulatory type activities well, and thereby have higher accuracy for activity intensity or energy expenditure metrics.
Mm.
So that's kind of the main thing we look at. Again, sedentary behavior is typically best assessed with the thigh overall. You've got to measure or weigh some of those things against compliance, though, with wearing the devices, right? The hip wear, compliance is okay depending on your population. Ankle monitors, we've seen a lot of indication that those are pretty good for especially measuring step counting and such. People don't like wearing ankle monitors. I think there's a perception, like at least here in the U.S., some of the feedback we've got is that people feel like they're wearing a police monitoring device because if you get in trouble with law enforcement and they're tracking your location, you have a device placed on your ankle, and so there's a very negative connotation associated with an ankle worn device, and so we've had trouble with compliance with that type of a device. And the thigh devices, typically you have to tape them on. And so you have to shave any hair off of the spot, and then you tape it in place. And for most people, it's not too uncomfortable. It can cause a little bit of skin irritation sometimes. But the biggest thing with that is they'll bump it into things. Like if you're sitting at a desk, and even if they're pretty low profile, there's not a lot of margin. So they'll run into things with it, or they'll put things in their pocket that hit it, or whatever it is. And so the thigh device, at least for us, has not been very favorable in terms of participant preference for a device location. Does that answer your question?
It does. So basically, there's a lot of pros and cons. There might be even connotations from ankle-worn devices. So it's quite complicated in a way to choose which one to select for your research project.
It is. And I guess another thing I would mention, we've done a lot of work looking at multiple accelerometer placements. So for example, if you wear a monitor on the ankle and the wrist, does it achieve better accuracy than just wearing it on the wrist? Or if you wear it on the hip and the ankle, or whatever combinations, or let's say you wear it in 5 different locations, is there a benefit in terms of accuracy? And that might sound kind of crazy in the sense that if you can't get people to wear a single ankle-worn device, how are you going to get them to wear 5 devices on the body? The compliance and the burden to participants is really, really high. And I guess the thought behind that is the technology that we're using is changing so fast, both in terms of how long we can record activity. Most monitors now will last several weeks to a month. What kind of sampling rate we can get. So, right now the actigraphs, which are just your kind of out of box research grade device, that can sample 100 samples per second for a couple weeks. So we can get a ton of data. The other thing is devices are getting much, much smaller. I've even seen prototypes for accelerometer sensors that can be put in something that looks like a Band-Aid. And then you would put it on your wrist or your ankle or in both locations, and that can record data. And so as technology improves, even if right now it's not feasible to have people wear an ankle-worn device, the idea that in a few years we might get a sock or a shoe that just has an accelerometer embedded in it, or we can just get like a piece of tape that has an accelerometer embedded in it, that for us warrants looking at these body locations for accelerometer wear, because it's very likely that in the near future that things like people not wanting to wear a device on their ankle because they think it looks bad, or not wanting to wear it on their thigh because they run into things with it, those are going to become less and less of issues as the technology miniaturizes over time. So I think those are still valuable questions to be asking. What are the placement sites, even if compliance isn't great? And does multiple device locations improve accuracy? I think are still very relevant questions. And so we've done a lot of work in that. We've seen surprisingly low benefit in using multiple accelerometers. In other words, accuracy increases very little if you move beyond one device for most of our outcomes of interest. I think if in the optimal setting, we would probably use some kind of a 2-device combination. So either like wrist hip or wrist ankle. If the technology was really, really small and we didn't have any data storage limitations and people would wear them with high compliance, that would probably be our best setup. So you're capturing both the upper and lower bodies, or the upper body and the torso, so you can get the best of both things like sleep assessment as well as sedentary behavior or stepping, those types of things.
So devices or sensors getting smaller and easier to wear. What else would you like to see in the activity monitors or activity trackers in the future?
So the devices themselves, is that what you're asking about?
Could be devices itself or the applications or how we use them.
Yeah, so the monitors themselves, I think certainly miniaturizing is going to be important. The other thing in our field is if we've relied almost exclusively on the accelerometer sensor. We call them accelerometers. Really, they're activity monitors with an accelerometer sensor. Some devices now have more sensors than just an accelerometer. So I mentioned gyroscope earlier. So a magnetometer, so sensing direction, would be another one. I think addition of sensors like that, or even a light sensor, a lux sensor, so that you can determine things like, is it night or daytime? Are they inside versus outside? Those might provide some helpful contextual data in order to understand how or where activity is happening. So I think the addition of different sensors is still worth doing. Certainly heart rate, if you can capture heart rate accurately, because that's a physiologic measure versus just a movement measure, that could have a large benefit in terms of how well we measure things or how we can differentiate intensity or sleep versus wake. So I am excited for the possibility of these multi-sensor devices and the continued use and development of those. The other big piece, I think, is that because I'm on the model development end, my research group has developed lots of machine learning models, which, we've validated or cross-validated in relatively small samples. We've shown in most cases that they seem to provide some improved accuracy over your traditional cut point techniques, let's say, if we're trying to characterize activity intensity. The problem is that these models are hard to implement, and so it takes quite a bit of time or effort and familiarity with software programs like R or MATLAB to be able to actually implement deploy these models to get physical activity outcomes from a data set. And so most researchers either don't have the skills or the time to do that. And so they'll opt for methods that are much easier to do, right? And so we see things like our cut point methods continue to be overwhelmingly popular in terms of ways to characterize sedentary, light, moderate, and vigorous activity. It's not because we think they're better, it's because they're so much easier to use. And so I hope the field can develop ways to better implement these more advanced analytic models. Because first, we've got to see how they work and how well they work in larger populations. But then also, the ones that do seem to work better, that do improve our measurement accuracy, we have to have the capability to adopt on a large scale and make them easy enough to use so that end users will actually use them in their research.
And what do you see as a replacement for the cut points? What do you think is the best or the most expected measure?
It's a really good question. The cut points, even as early as I think it was the MSSE 2012. They do they've done a couple special editions related to physical activity measurement. And in 2012, they recommended moving away from cut points in favor of these more advanced analytic methods. Now, there have been a bunch that have been created. Some are, a lot of them are raw data models. So instead of looking at proprietary counts, which for an actigraph would be different than an Actical or whatever other company, it's supposed to increase the translatability of these models across different device brands. So we're not just dependent on a single brand. And then there have been a range of different models. Some actually are just using thresholding techniques, but with raw data. So it almost looks like a cut point, but it's based on a raw data signal versus counts. I think there's some potential value there. Then there are the more advanced machine learning type models. And there's a whole range of those. More recently, what we've seen is deep learning models be applied to accelerometer data in the hopes of improving energy, not just energy expenditure, but whatever our outcome measures, activity outcome measures of interest are. So there's a lot going on. I don't know if it's entirely clear what the best path forward is because we haven't seen these implemented on a larger scale to understand how they work outside of their validation set or sample, let's say. And the other thing is there's a little bit of I guess people are a little bit reluctant to implement some of these because machine learning models or these more advanced analytic models it's less clear how they work, how they derive outcomes of interest. We call them black box methods because you feed something into it, it spits something out in the end. You don't really know what the process was that used to derive the energy expenditure or the activity intensity. And because of that, it's harder to predict how the monitors will work or how the analytic techniques will work when you apply them in a new population. Whereas for something like cut points, it's much easier to gain an insight into which types of populations a given set of cut points might work well in versus not, what types of activities might be under predicted in terms of intensity versus over predicted. There's a lot of, we can anticipate a lot with cut points in terms of how they work. It's much harder to do that with machine learning models, even to the point, and this is something that still gets me with machine learning models. So if let's say you have a data set that you're using to validate or to develop a machine learning model, if you use the exact same data set and develop the same type of machine learning model, if you do it 2 different times, you don't necessarily get the same machine learning model predictions on the back end, which seems strange because if you took the same validation set and you developed cut points, and then you develop the cut points again, they would be identical in the way that, based on the way that you develop it, or like a linear regression line. If you take the same data set and you redevelop the line, it will be identical. And so there's a certain level of unpredictability with machine learning because the models are all, even if, again, you take the same data set, they may not develop entirely the same way. And so there's a little bit of concern then with how they'll function in a different population. So that's the big thing right now. And then deep learning, it's the same idea but taken to an even more extreme level. So deep learning is even more of a black box technique, at least with your conventional machine learning models like a neural network or a decision tree. We pick the features of the data. So we take the raw data, we compute certain summary metrics in a given window. So, for example, mean, variance, maybe you take percentiles of the acceleration signal, those types of things, and then you use those as the inputs. Deep learning, you do even less of that. And so I'm not as familiar with it because I've got some colleagues who do more of the, kind of in the weeds analysis, but my impression is we have even less control over what inputs we take and put into the model. It's more of it decides which inputs are the most valuable. And so there's even less user input and there's more of a black box feel on these deep learning methods. And so the more we move into those, the more we don't understand how they work. And I'm not saying that just because I don't understand it. I think inherently we can't know what's going on in the background as much as we would with the simpler methods like a cut points or a linear regression type technique. And so we don't know how they work, and we don't know how they will fare in new data sets. And those are two of the big things that hold us back from moving forward.
Yeah, that's very interesting. So it's kind of black box, but if in the validation it shows that it is more valid than for example the other methods, is the validity the only important thing, or why would we need to know how it is done?
Yeah, that's a good question. And so the same question gets used for consumer monitors, right? Like, so if I take a Fitbit or I take an Apple Watch and I put it on, I don't have any idea what kind of inputs it's taking. And I just know that it's going to tell me how many steps I took or how many calories I burned or whatever, right? With the consumer monitors, if you get the right answer or close to the right answer in terms of steps, does it really matter what's going on in the background, right? Some people would say yes, some people would say no. I think that's a bit of an open question. I think really for me, the concern with not knowing how the models or what's going on to derive the outcome metrics is, like I was saying before, it gives you less information in order to understand how those models will work if applied to a new population, or even if it's the same population but a population that's changed their behavior. Can you really be confident that the monitors will accurately assess that behavior change? Like, if I want people to be more active or engage in more of these specific types of activities, can I be confident that the models will accurately recognize that? And if they report a difference in activity, can I be confident that's a true difference rather than just a change in measurement capabilities? If that makes sense.
Yeah, it does make sense. Thanks for joining us this week on Physical Activity Researcher Podcast. If you like the show, make sure you never miss an episode by subscribing or following the show on Twitter. This podcast is made possible by listeners like you. Thank you for your support. If you found value in the show, we would really appreciate a rating on Apple Podcasts or whichever app you're using. Or if you would, in a real old school way, simply tell a friend about the show. It would be a great help for us. We have a fantastic lineup of guests for forthcoming episodes, so be sure to tune in. Thank you all for your support and have a great day.